The Soviet Union was a nation that measured power in steel, scale, and sheer audacity. Across 5 decades of Cold War competition, Soviet engineers built some of the largest, heaviest, and most unconventional machines the world has ever seen. Aircraft that dwarfed modern jets, submarines the size of apartment blocks, mining giants taller than buildings, and missile carriers that looked more like rolling fortresses than trucks. These machines weren't just tools, they were political statements. Massive proof-of-concept creations meant to show that the USSR could outbuild, outlift, and out-engineer any rival. Some became legends, others failures, and many were simply too big or too strange to survive the fall of the Soviet state. But each one reveals a piece of the colossal ambition that defined Soviet industrial power at its peak. The Antonov and Tu-25 Mriya, the largest aircraft ever to fly. The Antonov and Tu-25 Mriya was the crown jewel of Soviet aviation, a flying giant so massive that nothing else on Earth has ever matched its size, wingspan, or lifting ability. Developed in the 1980s by the Antonov Design Bureau in Kyiv, the An-225 was built for one purpose: to carry the Buran space shuttle and the enormous components of the Soviet Energia rocket program. At 84 meters long and weighing more than 600 tons when fully loaded, it dwarfed every other aircraft ever built, including the American C-5 Galaxy and Boeing 747. The Mriya wasn't just big, it was unprecedented. The aircraft used 6 enormous Progress D-18T turbofan engines, each powerful enough to lift an airliner on its own. Together, they produced more than 300,000 pounds of thrust, allowing the An-225 to take off, carrying payloads no other plane could handle. Its wingspan of 88.4 meters required unique taxiways, custom hangars, and highly trained crews just to maneuver it on the ground. Even without cargo, the Mriya was a technical marvel. 32 landing gear wheels distributed its weight. The twin tail fins prevented turbulence from the Buran orbiter riding on its back, and the cargo bay was so large that entire trains could theoretically fit inside. Although built for the Soviet space program, the An-225 found new life after the USSR collapsed. Antonov Airlines put it to work as the world's ultimate heavy-lift cargo aircraft, transporting oversized loads such as power plant generators, massive military equipment, and disaster relief supplies. Its ability to carry up to 250 tons in a single flight meant it often handled jobs previously thought impossible. Whenever the Mriya landed at international airports, crowds gathered to witness its enormous presence. It became a symbol of engineering ambition, surviving long after the nation that created it. Tragically, the An-225's career was cut short in 2022 when it was destroyed during the battle for Hostomel Airport in Ukraine. The world reacted with shock, treating the loss not simply as the destruction of an aircraft, but as the end of a technological era. Engineers have discussed rebuilding the plane using unfinished components from Soviet times, but the cost and complexity make the future uncertain. Even in its absence, the Antonov and Tu-25 remains unmatched. It was the ultimate demonstration of what Soviet aerospace engineering could achieve, an aircraft so large and capable that decades later, no nation has attempted to build anything like it again. The Mriya was more than a machine. It was a dream, and its legacy continues to loom large in aviation history. The Typhoon-class submarine, the largest submarine in human history. The Typhoon-class submarine, known in Russia as Project 941 Akula, holds a record no other nation has challenged. It is the largest submarine ever built. These Cold War Leviathans were created in the late 1970s to carry the USSR's heaviest nuclear ballistic missiles across the Arctic Ocean. At 175 meters long and nearly 24 meters wide, the Typhoon was essentially an underwater fortress, so gigantic that it resembled a small surface ship more than a traditional submarine. Nothing else in naval history has matched its size or intimidation. Unlike conventional submarines, the Typhoon used a double-hull configuration with twin pressure hulls running side by side, plus a third central compartment. This unusual design provided immense internal volume, allowing the submarine to withstand Arctic ice pressure, survive direct torpedo damage, and to house surprisingly spacious crew quarters. Sailors on a Typhoon enjoyed amenities rare for submarines: a gym, swimming pool, sauna, and comfortable sleeping quarters. These luxuries were not for morale alone. The submarines were designed for months-long patrols under polar ice, far from any support. Power came from two massive nuclear reactors driving more than 100,000 horsepower through huge propellers. Despite its enormous bulk, the Typhoon could glide silently through deep waters, using advanced sound-damping systems to evade NATO detection. Its primary weapon was the R-39 RIF missile, the largest submarine-launched ballistic missile ever deployed, each carrying multiple nuclear warheads capable of striking targets across continents. With 20 missile tubes arranged along the upper deck, the Typhoon could deliver overwhelming firepower in a single launch sequence. Operating primarily in the Arctic, the Typhoon lurked beneath thick ice sheets where enemy ships and aircraft could not reach it. Special reinforced structures allowed it to surface directly through ice layers. This strategic mobility, combined with its missile capacity, made it one of the most feared deterrent platforms of the Cold War. NATO analysts regarded it as the ultimate Soviet second strike weapon, a machine that guaranteed retaliation even in a full-scale nuclear conflict. Yet the Typhoon's size and complexity made it extremely expensive to maintain. After the Soviet collapse, funding evaporated, and most of the fleet was retired or dismantled under disarmament agreements. Only a single hull, Dmitry Donskoy, survived into the 21st century as a missile test platform. Though its era has passed, the Typhoon remains unmatched in scale and presence. It was the apex of submarine engineering, a steel giant beneath the ice, built during a time when size, power, and strategic dominance defined Cold War military ambition. The bagger 288 Soviet rival, the Takraf ERS-700 bucket wheel, the mining titan of the East. The Takraf ERS-700 bucket wheel excavator was one of the Soviet bloc's greatest achievements in heavy mining equipment, a colossal strip mine machine built to compete with the giant German bucket wheel excavators such as the Bagger 288. Constructed in East Germany under Soviet direction, the ERS-700 stood more than 70 meters tall, stretched almost 200 meters long, and weighed thousands of tons. Its purpose was to remove unimaginable volumes of overburden in massive open-pit coal operations across the Eastern Bloc. In both size and capability, it was a true mining titan of the Soviet industrial world. The core of the machine was its massive bucket wheel, a rotating steel disc lined with dozens of bucket scoops that carved into earth with relentless efficiency. As the wheel turned, each bucket scooped up tons of soil and rock, dumping the material onto a system of conveyor belts that snaked through the machine's full length. This conveyor system transferred the earth to auxiliary machines, or directly to waste piles. The ERS-700 could move tens of thousands of cubic meters of material per day, a volume impossible for traditional excavators or trucks to match. Its enormous size required a complex support structure. The excavator moved on multiple sets of heavy crawler tracks, each powered by electric motors fed by an external power grid. Because the machine's weight exceeded that of large warships, its ground pressure had to be evenly distributed across the tracks, allowing it to crawl slowly but steadily across open-pit mines. Engineers designed the ERS-700 to operate continuously, running day and night with only brief maintenance shutdowns. Operating such a giant demanded a full crew. Control rooms inside the machine monitored power systems, conveyor alignment, structural loads, and bucket wheel performance. Observers stationed along walkways inspected critical components, and technicians performed constant mechanical checks. Despite its massive appearance, the ERS-700 required precise operation. Even small errors could cause misalignment, conveyor jams, or structural stress. After the fall of the Soviet Union, many ER-700 units continued operating for decades, particularly in Germany, Poland, and Eastern European coal mines. Some were eventually retired due to high maintenance costs and environmental policies reducing coal extraction. However, a few still function, slowly crawling across open pits just as they were designed to do decades ago. The Takraf ERS-700 remains a symbol of Soviet-era industrial ambition, enormous, relentless, and engineered for one purpose: moving Earth on a scale few machines in history have ever matched. The Lun-class ekranoplan, the flying warship of the Caspian Sea. The Lun-class ekranoplan stands as one of the most spectacular and unconventional machines ever built by the Soviet Union. A gigantic flying warship designed to skim just a few meters above the water at aircraft-like speeds. Developed during the late Cold War under the guidance of aerospace pioneer Rostislav Alexiev, the Lun-class was the only operational military ekranoplan in the world. It combined the speed of a jet, the seaworthiness of a ship, and the stealth of a low-flying missile platform. At 240 feet long and weighing more than 380 tons, it was larger than a Boeing 747, yet flew lower than a helicopter. The Caspian Sea became its runway, proving grounds and battlefield concept zone. The Lun achieved flight through the wing-in-ground effect, a phenomenon where air compressed between the wings and the water surface creates lift. This allowed the Lun to fly at around 10 to 20 feet above the waves while traveling at almost 300 miles per hour. By staying so low, it remained hidden from radar systems that scanned for high-altitude aircraft. For the Soviet Navy, this made the Lun a potential strike weapon capable of ambushing enemy carrier groups before they could react. Its armament underscored this role. 6 massive P-270 Moscow anti-ship missiles mounted atop the fuselage. These supersonic weapons traveled at Mach 3 and carried warheads powerful enough to cripple or sink major warships. The machine's propulsion system was equally extreme. 8 enormous Kuznetsov NK-87 turbofan engines lined the nose, blasting downward during takeoff to generate lift over the water's surface. Once airborne, some engines throttled back, while others pushed the craft forward across the sea at astonishing speed. Pilots described flying the Lun as a constant battle with the air cushion beneath it. Too high, and it lost lift. Too low, and it risked striking a wave. The ekranoplan demanded intense focus and specialized training. Despite its promise, the Lun-class faced daunting limitations. Rough seas made flight dangerous, fuel consumption was enormous, and maintenance was relentless due to constant saltwater exposure. Only one unit, the MD-160, ever reached operational status. A second hull intended for a medical rescue ekranoplan was left unfinished. After the Soviet collapse, the Lun was mothballed on the Caspian coast, where it sat for decades like a stranded metal whale. Though it never saw combat, the Lun-class remains one of the most breathtaking military machines ever imagined. A flying warship that skimmed the waves, too strange and too ambitious to survive outside the feverish innovation of the Cold War. The MAZ-7907 missile carrier, a 24-wheeled land battleship. The MAZ-7907 was one of the Soviet Union's boldest and most extravagant land vehicles, a monstrous, 24-wheeled missile carrier built to transport and potentially launch the RT-23 Molodets intercontinental ballistic missile. Stretching 90 feet long and weighing roughly 200 tons, the MAZ-7907 wasn't a truck so much as a rolling battleship. It represented the pinnacle of Soviet mobile missile doctrine, a strategy built around dispersing nuclear weapons across vast territories to keep them hidden from NATO surveillance. With its futuristic architecture and enormous scale, the 7907 remains one of the most extraordinary military vehicles ever engineered. The most remarkable aspect of the MAZ-7907 was its propulsion system. Instead of a traditional drivetrain, the vehicle relied on a gas turbine electric setup decades ahead of civilian hybrid technology. A massive GTD-1000 gas turbine engine, similar to those used in tanks and naval vessels, powered 2 electric generators. These generators supplied electricity to 24 individual wheel hub motors, giving each wheel independent drive. This allowed the machine to creep forward smoothly despite its massive weight, and the configuration provided redundancy. Even if some motors failed, the carrier could still move. Steering was equally complex. All 12 axles were steerable, allowing the enormous vehicle to turn more tightly than its size suggested. The chassis used an articulated central joint that let the vehicle bend around obstacles, a necessary feature for navigating rough or forested terrain. In theory, the MAZ-7907 could deploy its missile from remote, undeveloped areas, making it harder for enemy satellites or bombers to detect and target. However, the vehicle's ambitious design also caused major problems. Its sheer size limited where it could operate. Soft ground posed significant challenges, and its enormous weight often caused it to sink or bog down. Fuel consumption was enormous, maintenance was complicated, and the electric hub motor system suffered from heat buildup during long-distance travel. Only one prototype was fully completed, and testing revealed just how impractical the concept was. When the Soviet Union collapsed in 1991, the expensive mobile ICBM program was halted. The lone MAZ-7907 was left abandoned for years until it was eventually recovered and partially restored. Today, it survives as a relic of Cold War excess, a land colossus created for a nuclear strategy that vanished before the machine could ever fulfill its mission. The Kharkovchanka Antarctic Tractor, the Soviet rolling polar base. The Kharkovchanka Antarctic Tractor was one of the Soviet Union's most impressive cold-weather engineering feats, a massive tracked machine designed not just to travel across Antarctica, but to live there. Built in the late 1950s at the Kharkov tractor plant, the Kharkovchanka served as a self-contained mobile station capable of carrying crews, supplies, laboratories, and sleeping quarters across some of the most hostile terrain on Earth. Where Western expeditions relied on tents and portable shelters, the Soviets brought an entire rolling apartment. Based on the ATT heavy artillery tractor, the Kharkovchanka used a powerful diesel engine and oversized tracks to float across deep snow, ice shelves, and sastrugi formations. Its 35-ton body carried an insulated superstructure mounted directly on the chassis. Inside were bunks, a kitchen, a workshop, radios, storage, and heating ducts running through the floor and walls. It functioned as a warm refuge where scientists could cook meals, repair equipment, and sleep in relative comfort while traveling for weeks at a time through -60°C temperatures. The tractor was essential for the USSR's ambitious plan to supply inland Antarctic stations such as Vostok, a remote base positioned near the coldest point on Earth. Kharkovchankas pulled long trains of cargo sleds loaded with fuel drums, building materials, and scientific gear. A convoy of several tractors could transport hundreds of tons of supplies over distances exceeding 1,000 kilometers. Although speeds rarely exceeded 10 miles per hour, their reliability made large-scale expeditions possible. Living conditions inside the Kharkovchanka were both impressive and imperfect. The warmth and insulation made long journeys survivable, but the living module sat directly over the engine. Heat from the machinery often melted the snow beneath the tractor, causing it to sink slightly overnight. Access to the engine was only possible from outside, forcing mechanics to step into brutal Antarctic storms for repairs. Despite these frustrations, the tractor proved strong and dependable. A second generation, the Kharkovchanka II, appeared in the 1970s. It separated the living quarters from the engine compartment, improved insulation, and increased payload capacity. These vehicles served 4 decades, becoming icons of Soviet Antarctic exploration. Today, abandoned Kharkovchankas remain frozen in place across the Antarctic plateau, preserved by the extreme cold like steel time capsules. They stand as monuments to an era of bold polar engineering, a time when the USSR decided that if Antarctica was too harsh for humans, they would simply bring a house on tracks. The Zubr-class LCAC, the world's largest military hovercraft. The Zubr-class LSAC, known in Russia as Project 123 2.2, remains the largest military hovercraft ever built. a monstrous amphibious assault vessel capable of lifting tanks, armored vehicles, and hundreds of troops directly onto hostile shores. At 57 meters long and with a displacement of over 550 tons, the Zubr is not just a hovercraft. It is a floating, unlike traditional landing craft that crawl through surf zones. The Zubr rides on a cushion of pressurized air, allowing it to storm across water, ice, sand, and marshland at speeds that rival fast naval patrol boats. The Zubr's power comes from a brutal set of gas turbine engines, 5 in total. 2 enormous lift fans create the air cushion beneath its reinforced skirt, while 3 propulsion turbines blast the craft forward at speeds exceeding 60 knots. This allows the Zubr to approach beaches that are completely inaccessible to ships. It can cross obstacles, leap over mines, and land troops on terrain unsuitable for any wheeled or tracked vehicle. Its ability to bypass coastal defenses makes it a potent amphibious warfare asset. The hovercraft's carrying capacity is equally impressive. It can transport 3 main battle tanks, 10 armored personnel carriers, or over 450 fully equipped troops. A massive folding bow ramp allows rapid unloading directly onto land, enabling armored units to charge forward seconds after landing. For fire support, the Zubr mounts rocket launchers, close defense cannons, and electronic warfare systems. In practice, it acts as both a landing craft and a frontline assault vehicle. Constructed primarily from aluminum-magnesium alloys, the Zubr's hull is designed to withstand impacts from ice and debris while maintaining low weight. Its multi-deck interior includes specialized compartments for troops, vehicles, command systems, and crew operations. The engineering complexity of such a vessel is enormous. Maintaining the skirts, turbines, and lift systems requires constant attention, and the craft's operational cost is far higher than that of conventional landing ships. Only a handful of Zubr-class hovercraft were ever built, and their service history spans Russia, Ukraine, and China. Despite their limited numbers, they remain unmatched in size and capability. No other military force has built a hovercraft even close to the Zubr's scale, making it one of the Soviet Union's most extreme and visually stunning engineering achievements, a thunderous beast designed for lightning-fast coastal invasion. The TM-3-12, railway battleship, a train armed with battleship cannons. The TM-3-1-2, railway battleship, was one of the Soviet Union's most extraordinary wartime machines, a 300-ton armored train mounting a massive 12-inch naval cannon originally designed for pre-World War I dreadnought battleships. Built in the 1930s as global tensions rose, the TM-3-1-2 represented an unusual fusion of naval firepower and railway mobility. Its purpose was to deliver devastating long-range bombardment from fast-moving positions deep inside Soviet territory. In an age before precision air power dominated battlefields, the TM-3-12 acted as a roving coastal artillery battery that could appear, fire, and disappear before enemy forces could respond. The train revolved around its enormous 305-millimeter gun. This cannon, capable of firing 400-kilogram shells over distances of more than 25 kilometers, was mounted on a reinforced railway carriage equipped with stabilizing outriggers and recoil-absorbing structures. When in firing position, the crew lowered massive ground anchors and rail clamps to prevent the gun's recoil from damaging the tracks. Despite its size, the platform could be re-aimed and repositioned relatively quickly, giving it more flexibility than fixed coastal batteries. Supporting the gun carriage were several armored cars containing ammunition storage, crew accommodations, communication systems, rangefinders, and generators. The locomotive itself was usually heavily plated with armor to withstand shrapnel and small arms fire. Crews operated in tight, noisy conditions, but the mobility gave them a significant tactical edge. The train could be moved from one firing position to another by simply advancing along the rails, and the Soviets often relocated the TM-3-12 to avoid enemy counter-battery fire. The first major action for the TM-3-12 came during the Winter War against Finland in 1939–40. From fortified rail lines, it shelled Finnish defensive positions with destructive effectiveness. During World War II, the TM-3-12 served in the defense of Leningrad, using its heavy shells to engage German artillery and supply hubs far behind enemy lines. Its armored design and mobility made it remarkably difficult to destroy. When threatened, crews often moved the train into tunnels or forested rail sections to evade air attack. However, the machine had limitations. It relied entirely on intact railroads and required extensive preparation to fire safely. As aircraft and mobile artillery improved, the concept of the railway battleship grew outdated. Even so, the TM-3-12 served well into the Cold War before retirement. Today, one surviving unit stands preserved as a museum centerpiece, symbolizing one of the boldest and strangest artillery innovations ever attempted: a battleship gun roaring from the rails. The Energia rocket, the most powerful Soviet rocket ever launched. The Energia rocket stands as the most powerful launch system ever developed by the Soviet Union and one of the most capable heavy-lift rockets in world history. Created in the 1980s by the Energia Rocket and Space Corporation, it was designed as a modular super booster capable of launching massive military payloads, heavy space stations, and even the Soviet Buran space shuttle. At its peak, Energia could lift more than 100 tons into low Earth orbit, rivaling the Saturn V and exceeding the capability of most modern rockets. Energia's power came from its unique two-stage architecture. The core stage burned liquid oxygen and liquid hydrogen using 4 RD-0120 engines that match the efficiency of the NASA's Space Shuttle main engines. Attached to the core were 4 strap-on boosters, each equipped with an RD-170 engine cluster. These engines were, and remain, the most powerful single-chamber liquid fuel engines ever built. Combined, the rocket generated nearly 7.5 million pounds of thrust at liftoff, allowing it to deliver unprecedented payload masses into orbit. Unlike the American shuttle system, Energia was designed to carry multiple types of payloads mounted on its side or top. Its first launch in 1987 carried the Skif-DM, a prototype space-based laser platform intended for orbital defense. Although the payload malfunctioned and fell back to Earth, Energia itself performed flawlessly. Its second flight in 1988 launched the Buran space shuttle, which completed a fully automated orbital mission and returned safely. The success demonstrated Energia's incredible versatility and reliability. Energia was meant to be the foundation of a new Soviet heavy-lift era, supporting large space stations, lunar bases, and interplanetary missions. However, the collapse of the Soviet Union ended the program abruptly. Massive costs, political instability, and lack of industrial capacity made further launches impossible. The rocket's infrastructure fell into disrepair, and no complete Energia was ever launched again. Despite its short operational life, Energia left a profound legacy. Its RD-170 engine family survives in modern rockets worldwide, including the Russian Zenit, Angara, and even American launch vehicles through licensed variants. Engineers still regard Energia as one of the most advanced heavy-lift platforms ever built. In the end, Energia was a symbol of Soviet ambition. Powerful, innovative, and tragically short-lived, it represented what the USSR could achieve at its technological peak, a super-heavy rocket whose capabilities the world has only recently begun to match again. The Mir deep-sea habitat and submersibles, the Soviet oceanic giants. The Mir deep-sea submersibles were among the most ambitious and technically impressive machines ever produced by the Soviet Union. Built during the 1980s, at a time when deep ocean exploration was largely dominated by Western navies and research institutions, the Mir 1 and Mir 2 were designed to go deeper, stay longer, and explore farther than almost any submersible in existence. Each craft was capable of descending to 6,000 meters, giving Soviet oceanographers access to nearly the entire ocean floor. To achieve this, engineers constructed a titanium pressure sphere capable of withstanding pressures greater than those found inside the barrels of artillery cannons. The Mir program was originally conceived as part of a broader Soviet initiative to establish long-term underwater habitats and deep ocean laboratories. Although the full scope of that vision was never completed, the submersibles became the centerpiece of the USSR's deep-sea capability. Inside each Mir, a crew of 3 operated in cramped but meticulously designed conditions. Banks of instruments, cameras, robotic arms, and sampling equipment allowed them to interact with an environment darker than moonless night and colder than liquid nitrogen. What made the Mir submersibles so effective was their balance of durability and agility. Their propulsion system allowed them to maneuver with precision, an essential capability when studying fragile hydrothermal vents, delicate volcanic structures, or shipwrecks resting precariously on the seabed. Sophisticated lighting systems illuminated the abyss, capturing footage that astonished scientists around the world. Their manipulator arms could gently retrieve biological samples or anchor instruments into volcanic rock. Following the collapse of the Soviet Union, the Mir submersibles found new life on the international stage. They played starring roles in famous expeditions to the wreck of the Titanic, exploring its decaying hull and helping film the iconic footage used in James Cameron's Titanic. They descended to the battleship Bismarck, explored Lake Baikal, and investigated hydrothermal vents in the Pacific. Their reliability surprised many Western researchers, who discovered that these Soviet-built machines were among the toughest and most capable submersibles ever engineered. The broader Soviet dream of underwater habitats never materialized, but the Mir program endured as a symbol of what the USSR could achieve when it pushed beyond technological limits. Even today, decades after their construction, the Mir submersibles remain operational, a testament to Soviet metallurgy, engineering, and vision. In the world of deep ocean exploration, few machines have matched their combination of depth, endurance, and historical importance. The N-1 moon rocket, the 100-meter monster that never reached space. The N-1 moon rocket was the Soviet Union's colossal attempt to send cosmonauts to the moon, a project driven by intense Cold War pressure and the desire to surpass the United States. Standing over 105 meters tall and weighing nearly 3,000 tons, the N-1 was an engineering giant rivaled only by NASA's Saturn V. Its purpose was to launch the Soviet L-3 lunar landing complex, a spacecraft designed to send a single cosmonaut to the lunar surface. Yet, despite its monumental scale and national importance, the N-1 became one of the most dramatic failures in aerospace history. At the heart of the rocket's difficulty was its first stage, which used 30 NK-15 engines arranged in a massive circular cluster. Because the USSR lacked a single large engine comparable to the American F-1, Soviet engineers were forced to rely on numerous smaller units. Coordinating these engines required the sophisticated Chord control system, which monitored each engine and attempted to shut down faulty units during ascent. In practice, however, the system became overwhelmed by vibrations, fuel pressure fluctuations, and cascading failures. Between 1969 and 1972, the N-1 launched 4 times. All 4 attempts ended in catastrophic explosions. The second launch, in July 1969, produced one of the largest non-nuclear detonations ever recorded when the rocket rose barely 200 meters before falling back onto the pad and erupting in a massive fireball. The blast destroyed the entire launch facility and set the lunar program back years. Unlike NASA, the Soviet Union never conducted full-scale ground tests of the N-1's stages. Budget constraints, secrecy, inter-bureau rivalries, and political urgency forced engineers to treat each launch as a test flight. When key designers, including Sergei Korolev, died or were reassigned, the program suffered further setbacks. By the early 1970s, the USSR faced economic strain and shifting political priorities that made continuing the lunar effort difficult. Ironically, late-stage improvements to the N-1, featuring the highly advanced NK-33 engine, might have solved many of the rocket's problems. But before the upgraded version could fly, the government canceled the program. The remaining hardware was destroyed or repurposed, and the Soviet dream of a lunar landing faded quietly from public attention. Today, the N-1 remains a towering symbol of the limits of even the most ambitious engineering when faced with political turmoil, rushed development, and technological bottlenecks. A monster rocket built to conquer the moon, yet doomed to never leave Earth. The Belas 540, Pioneer Hauler, the first Soviet ultra-class dump truck. The Belas 540 was the first Soviet dump truck that genuinely entered the realm of ultra-class hauling, a breakthrough that transformed mining operations across the USSR. Introduced in the early 1960s, the 540 was designed to compete with heavy Western haulers and to replace aging, smaller Soviet trucks that could no longer meet the demands of rapidly expanding open-pit mines. With a payload of over 27 tons, it became the foundation for Belas's rise to global prominence in the heavy equipment industry. Built at the Belarusian automobile plant, the Bel AZ 540 featured a rugged design crafted for sheer endurance. Mining environments in the USSR ranged from scorching Central Asian quarries to the frozen pits of Siberia, and the truck had to perform reliably in both extremes. Engineers equipped it with a powerful V12 YAMZ diesel engine rated at around 375 horsepower, delivering the torque needed to haul heavy loads up steep inclines. The high-mounted radiator reduced clogging from dust and debris, a common issue in early mining trucks. One of the 540's signature traits was its distinctive asymmetrical cab, mounted forward and to the left of the engine. This unusual placement dramatically improved the driver's visibility of the loading area, haul road edges, and dump zones. The layout later became a defining hallmark of Bel-AZ designs and influenced Soviet industrial vehicle ergonomics for decades. Despite its relatively simple construction, the Bel-AZ 540 introduced several important innovations: hydraulic suspension systems, reinforced frames capable of absorbing enormous stress, and high-capacity braking designed for long downhill runs. Operators found the truck surprisingly reliable, even if Spartan. The interior was noisy, basic, and often freezing in winter, but the machine itself almost always completed its mission. The impact of the Belas 540 was enormous. It allowed Soviet mines to move more material with fewer vehicles, increasing efficiency across the board. It also paved the way for the massively larger Belaz trucks that followed, including machines carrying 120, 170, 240, and eventually 450 tons. Today's world record, Belaz 5710, capable of hauling 450 tons in a single load, traces its lineage directly to the 540. Many Belaz 540 trucks continued operating for decades, some surviving well into the 21st century. Their longevity stands as proof of their tough, straightforward engineering. The 540 was not the largest dump truck ever built, but it was the machine that brought the Soviet Union into the modern era of ultra-class mining, becoming the pioneer of one of the world's most iconic heavy equipment lineages. The Kirov-class battlecruiser, the largest warship built after World War II. The Kirov-class battlecruisers were the Soviet Navy's most imposing surface warships, combining the firepower of a battleship with the speed and reach of a missile cruiser. When the first ship, Kirov, entered service in 1980, it became the largest and heaviest surface combatant built by any nation since World War II, so massive that NATO classified it as a battlecruiser, reviving a ship category thought extinct. At over 28,000 tons, fully loaded, and stretching more than 800 feet long, the Kirov dwarfed Western cruisers and rivaled aircraft carriers in sheer presence. The Kirov-class was created during a period of intense Cold War naval competition. The Soviet Navy wanted a ship capable of countering U.S. carrier strike groups, enforcing long-range sea control, and projecting Soviet power across the world's oceans. To achieve this, Kirov was outfitted with an astonishing array of weapon systems. Its primary armament, the P-700 Granite SSN-19 shipwreck anti-ship missile, was designed to overwhelm carrier defenses with Mach 2.5 speed, massive warheads, and coordinated swarm algorithms. A single salvo from Kirov could cripple or sink multiple surface ships. The ship bristled with additional weaponry: long-range surface-to-air missiles, short-range point defense systems, torpedoes, rocket-assisted depth charges, and multiple gun mounts. Its sensor suite rivaled that of a small fleet, and its massive nuclear reactors eliminated the need for refueling, giving it extraordinary endurance. Kirov could remain at sea for years if properly supplied. But the most striking aspect of the Kirov-class was its hybrid power system. Two nuclear reactors worked in tandem with oil-fired boilers, giving the battlecruiser speeds exceeding 30 knots despite its enormous bulk. This combination of range, speed, and armament made it one of the most powerful surface combatants ever built. Yet, the Kirov-class also symbolized the limits of Soviet naval ambition. While the ships were formidable, they were also incredibly expensive to maintain. Their nuclear systems required specialized crews, extensive dockyard support, and constant inspections. After the fall of the USSR, the Russian Navy struggled to keep the massive vessels operational. Some were laid up for years, others cannibalized for parts, and only one, Pyotr Veliky, remains active today. Even so, the Kirov-class battlecruisers stand as some of the most impressive warships ever constructed. Enormous, heavily armed, technologically ambitious, and unmistakably Soviet in their brute force design philosophy. They embodied a moment when the USSR sought not just naval parity with the West, but naval dominance. The SPS-6 oil platform, the Soviet Arctic drilling megastructure. The SPS-6 oil platform was one of the most ambitious engineering projects ever attempted by the Soviet Union, a massive Arctic drilling installation designed to conquer the hostile waters of the northern continental shelf. Built during the 1980s when the USSR sought to develop its remote petroleum reserves and reduce dependence on foreign energy imports, the SPS-6 represented a bold effort to push industrial infrastructure into regions where temperatures plunged to minus 50 degrees Celsius. Icebergs drifted unpredictably, and storms could tear conventional rigs apart. Unlike typical offshore platforms used in warmer seas, the SPS-6 needed to survive crushing ice loads and violent winter conditions. Engineers designed it as a gravity-based megastructure, constructed from reinforced concrete and weighing hundreds of thousands of tons. Instead of floating, the platform sat firmly on the seabed, using its enormous mass to resist ice pressure. Its base was shaped to deflect ice flows, allowing sheets several meters thick to ride up and break under their own weight before reaching the main structure. This uniquely Soviet approach emphasized durability and brute force rather than mobility. The SPS-6 housed drilling equipment, accommodations for dozens of workers, power generation systems, workshops, and emergency shelters. Heavy insulation, heated ventilation circuits, and internal climate control were essential for preventing machinery from freezing solid. Every cable, valve, and hydraulic line was designed for sub-zero reliability. The platform also included a helicopter deck, often the only way to access the structure during winter, and emergency lifeboats built to withstand ice-choked waters. Constructing the SPS-6 was an immense logistical challenge. Components had to be fabricated in specialized shipyards, transported north by heavy-lift vessels, and assembled during brief summer windows when sea ice retreated. The platform's placement required precise seabed surveys, environmental stabilization, and enormous support fleets, including icebreakers, supply barges, and tugboats. When finally installed, the SPS-6 stood as a triumph of cold region engineering, capable of drilling in areas previously untouched by industry. Despite its engineering success, the SPS-6 also highlighted the economic and political pressures facing the late Soviet Union. Operating such a megastructure was extremely costly, and the collapse of global oil prices in the 1980s strained the USSR's energy budget. After the Soviet Union dissolved, maintenance funding dropped sharply, and the platform, like many Arctic projects, fell into partial disuse. Even so, the SPS-6 remains one of the most impressive industrial monuments of the Cold War, a massive, immovable fortress built to extract oil from one of the most hostile environments on Earth. It stands as a testament to Soviet ambition and to the extreme difficulty of working where ice never sleeps.